In this video, we will review over how to solve circuit problems, both series circuits and parallel circuits. We will begin with series circuits. In a series circuit, the resistors are wired one after another. We can see that right here. Since they are all part of the same loop, they each experience the same amount of current. In that figure, you'll see that they are all exist between the terminals of the battery, meaning they share the potential voltage, so that we would have our current equaling the same, but our voltage would be additive. Now let's look at an example of a series problem. Here I've drawn out a series circuit where we can see the voltage. We see our first resistor, our second resistor, our third resistor. Remember that our voltage, or volts, is in voltage, and our resistor is in ohms. And so this would be typically what we would need to fill out. We do remember that in a series circuit, our resistance, voltage, and current are the three components we'll be looking at. So I wrote each of the formulas over here for us. Again, just Ohm's law. We know that current in a series circuit is the same, and we know that voltage is additive. We're going to start by filling in the information that's been given to us in our diagram, so that we know that our resistance 1 is 8. We know that our resistance 2 is 4. We know that our resistance 3 is 12. And we know that our total voltage is 12. That's the information that has been given by our diagram. Our total resistance is additive, and so we will take our 8 plus 4 plus 12, and that gives us a total resistance of 24. Now that I have my total resistance and I have my total voltage, and this should be total right there, not 4, I can find my current. And so I can use the formula resistance equals voltage divided by current and solve in, and I get that my total current is 0.5. This being a series circuit, my current is the same throughout, so it is 0.5 all the way through. Now that I have my resistance and my current, I can do my voltage equals current times resistance, and I'll get my answers. If I want to check myself, then what I can do is look at my voltage is additive. 4 plus 2 plus 6 would equal the 12. My resistance is additive. 8 plus 4 plus 12 is 24, and my resistance is the same throughout. So that in a series circuit, our current is the same throughout, our voltage is additive, and our resistance is additive. And so we can use the formulas from the previous slide, and we can solve for any missing component. A parallel circuit has multiple paths with which the electricity can travel down, with different devices along the different paths. If one pathway is open or broken, the others can still carry electricity. Example would be our newer Christmas tree lights or household circuits. We can look at a diagram over here, and we can see that we have this as a path. We also would have this as a path. This area could be broken. We could still travel this way. This could be broken. We can still travel this way. So that in a parallel circuit, we have multiple loops, so that the current splits up among the loops with the individual loops current adding to the total current. In this case, what we're going to see is our current is additive regarding the junctions where we have our current in and our current out. However, our voltage will remain the same throughout. Now here I have drawn a parallel circuit where we can see our voltage. We can see that our resistors are parallel to one another, so we can see that we have different pathways that our electrons could flow. I have our equations over here, and then I have what we would need to fill out for our resistance 1, 2, 3 in total, our current 1, 2, 3 in total, and our voltage 1, 2, 3 in total. And so we're going to begin by filling in the information that we know. We know that our resistance is 10, 20, and 40. Now in this case here, when we've got this, and I made a boo-boo on this problem, so we're going to come back over here. The resistance in this problem is supposed to be 120 volts. Alright, so as we continue, we filled in our resistance 1, 2, 3. We've got our voltage. Our voltage in a parallel is the same all the way through. So I've got my voltage. Now that I have my voltage, I can come over and say that my current equals my voltage times R. And so I get 12 here, I get 6 here, and I get 3 there. Now, this is additive to get my total current, so I would add 12 plus 6 plus 3, and if I do that, I get 21. My resistance, I'm going to solve for that where I have my resistance equals my so what you're seeing here is I just erased it and cleaned up and made that a little bit clearer. And then I had written the resistance a little backwards. My resistance equals voltage divided by current. So now that I have that fixed, I can come over here and I can solve. My resistance would equal my voltage divided by my current. When we do the math on that, we would get roughly 5.7. And this is how you will go about solving your parallel circuit problems.